is that most calculators you can compute with base 10 and base E. Some you can't. But if I'm dealing with log, that's base 10. Easy enough. And I guess I need to put an approximate because these guys are not going to be real. So log, LOG, so LOG of 436. Approximately 3 decimal places, it says. So 0.639, and the next one is a 4. So 0.639. 2.639, I already forgot what it was. And this is going to be approximate as well. Natural log of 0.98. And you're going to need your calculators for these crazy word problems. And if I'm going 3 decimal places, negative 0.020. Or if you put negative 0.202, I don't care. Okay, here we go. Domains. And the further along in mathematics you go, the more important the idea of domain is. And that's going to be even true in brief calculus. For those of you who are going to be taking brief, first thing we're going to do in some instances is say, what's the domain? What's the domain? Because that's going to govern what our number line looks like that we're going to be working with. Because it restricts at times what my values can be. So if I look at what the definition of the domain of the logarithm is, if I look at the exponential, b to the x, if I take a look at his domain, because you've done transformation, so you know what the domain is. The domain of b to the x is what? All real numbers, right? No denominator, no radical, all real numbers. And his range, if I take a look at the picture, this might be helpful. What's his range? 0 to infinity, because he has an HA at y equals 0. So what is this going to mean to you? Well, logarithm is going to be bringing everybody back. His world consists of only numbers between 0 and infinity. So the domain of the log is 0 to infinity. He brings everybody back to a world that is all real numbers. So that the range of the log is all real numbers. And if I'm indeed dealing with the inverse, if the exponential has an HA at y equals 0, what must the logarithm have? We interchange who? X and y. So it's going to be a vertical asymptote. So he's got to have a VA at x equals 0 because x and y are reversed. Now what's going to be important to you as we move forward is that what you're taking the log of is going to be an expression and just not x. And what you're taking the log of has a name. It's called the argument. You notice that rational functions have denominators, right? And radicals have radicands. Logarithms have arguments. And since I'm dealing with the domain of the log, and it's the log to any base, by the way, only 0 to infinity is in his world, so that the argument must be positive. The argument must be positive. So here we go. Find the domain of each function. Natural log of x minus 1, in this case the argument is what you're taking the log of, is x minus 1. So that the argument must be positive. So that x minus 1 must be positive, or x must be greater than 1. So in this case, the domain of the function g is x greater than 1. This also gives you the VA. The VA is where this thing is equal to 0. So he has a VA at x equal 1. He's a translational shift 1 unit to the right. They're back. Log of x squared minus 1. Here the argument is x squared minus 1. Uh-oh. It's a polynomial. Or we know that the argument must be positive. X squared minus 1 must be positive. Now what do we do? This is 4-6. Well, in my world, I find the x-intercepts, because remember, the whole idea of touching and crossing affects where the y values are positive or negative. In order for y values to be positive, they must be above the x-axis. The graph must be above the x-axis, or the function must be above the x-axis. For the y values to be negative, the function must be below the x-axis. So I first go after the x-intercepts, and that's essentially where I solve the equality equation, x squared minus 1 equals 0. By the way, this is about a third of calculus of the brief. Well, I know that this is where x squared equals 0. Oh, come on, Peterson. X squared equals 1, or x equals plus or minus 1. These are multiplicity 1, so does the graph cross or touch? Cross, because it's multiplicity odd. Remember, lines cross, s's cross, multiplicity is odd, all cross. Multiplicity even basically makes a parabola and touches and bounces off. So that as I go onto the number line, I can put in -1, I could put in 1, they both cross. I think that's the notation he used. And then I pull a test point. My favorite test point, by the way, is 0. And I want to know, is x squared minus 1 positive or negative at x equals 0? So at x equals 0, 0 squared minus 1 is negative, so it's negative here. If it crosses, it moves to what? It changes, so positive. If it crosses, it changes, moves to positive. I'm interested in positive only. So the domain of this sucker is minus infinity to negative 1, union 1 to infinity. He's got two zeros, and that's plus or minus 1. He's got two VAs. So he doesn't exist here, but he exists on either side.